Good morning, all of you. Welcome to the course on artificial intelligence and soft computing. So, during our first chapter, we covered a lot of topics, and the first we discussed about the definitions of intelligence, right? When we talk about again, so this is a quick recap of the chapter one. So then we will move on to the chapter number two, right? As per the schedule, right? And initially, we discussed about what is meant by intelligent, human intelligence. When we talk about any person or any human is intelligent, right? In that intelligence is the combination of multiple abilities like reading, listening, and then understanding, and then perception, and then taking the decision, knowledge, interpretations, right? And decision making, implementations, right? Reading, writing skills, right? So all these skills which combines and make a person to be a more intelligent, right? Then we discussed about the different definitions of artificial intelligence. When you talk about artificial intelligence, it's a field in which, right, the scientists are the expert. They are trying to mimic a human being, right? They are trying to develop a model. That could be a mathematical model or a machine learning model or AI-based model. That model will try to act as well as do all activities like how we human being does a particular job, right? So this is what the idea behind the artificial intelligence, right? Then we discussed about the four definitions of or four dimensions of artificial intelligence. I could say that uh, the agents are the machines that think like a human, or I could say that intelligent agents are expert system, right? Which thinks like a human and then act like a human, right? The machine or the model which has the ability to think as well as act like how human being we take as well as we does all type of operations. Then the third the dimension is that when we talk about any AI model, right, which has the ability to think rationally. When you talk about the rational mode, out of, say, for example, if I'm taking any problem, for the problem, right, there could be any number of solutions, right? Out of the available solution or possible solution, if the expert system or the mathematical model or machine learning model, it has the ability to select the right one. When we talk about the right solution, again, it's the solution should be optimum. Might be the solution may vary from based on the concepts which we assume, right? Say, for example, in the traveling salesman problem, in a traveling salesman problem again, so that the solution or the goal state might be that how fast we are reaching the destination. Otherwise also based on the other factors, right? How comfortable the road is, right? I might be what are the other possible those sceneries which is there in the roads, so that I can enjoy my traveling more. So these are the different factors through which certain no solution to be identified. When you talk about a rational agent, right, a rational thing, so that is in that selecting the right one, right? Think rationally and then act rationally based on the decision which made the right one which has to be implemented. Then, so these are the four dimensions which also we discussed, right? Like think like a human and then act like a human, think rationally and then act rationally. Then also we discussed about the evolutions or the history of artificial intelligence, where it has started from the Alan Turing, and then where it is ended now, what we are using, whatever the technologies we have in the artificial intelligence domain. We discussed about the different history as well as evolutions. What are the new technology which are added with the existing and then which form completely new dimensions of artificial intelligence, right? Throughout the history we discussed, right? Also, we discussed about the different applications of artificial intelligence, right? Quickly, I will recap the few applications we discussed about the Facebooks and the social media applications. How the Facebook as well as the Twitter, which uses friend tagging, right? Auto suggestion, auto tagging, right? Based on your face recognition, who are all present in your photo which you upload on the Facebook, that photo will be automatically tagged to the people or the friends who are there in the photo which you have uploaded. That is automatically done by the Facebook auto tagging to the with the help of the face recognition. And then Twitter again, which uses a sentiment analysis to identify the mood of the person, whether after reading that feed or after reading the tweets, right, whether the person is happy or whether he's sad, or then whether he's angry, right? That emotions can be identified with the help of that the sentiment analysis process. And then we discussed about the other applications like um, navigations where no AI and then machine learning which uses no really where we can find out the shortest path after turning on your GPS in our mobile phone will feed the source and then destination automatically that will suggest as the correct path or the shortest path through which we can reach the destination. Suppose in case in between, suppose if you are taking any wrong directions, or in that situation also your GPS or your Google Map automatically finds out your location where you are. According to that, it will adjust the map. It will try to modify your route so that you will reach the destination, right? Or you will reach the correct destination. So these are some of the example, or I could say that example of how the AI which works in the Google Map. Then another example we added was again natural language processing, where there are a lot of applications which are now evolved using the natural language processing. Again, the Google Translation, I could say that Google Translation. Suppose if you are in a place where you whatever the signboard which is written in a different language, that language you are not able to read or you are not able to understand. That case is always you can use a Google Translator. You can open that application and then you can just turn on your camera and then you can just take the picture of that what is the content which is written on the signboard. Automatically your Google Translator will interpret and then so that will give you the your designated language. Suppose if you wanted to from Spanish into the Hindi or English language, so that automatic translation which takes place immediately and you will be getting that all the information which are written in the signboard. So again, so this is one of the application, right, where other than that we discussed about different assistants, right? I could say that the personal assistant like uh, iOS Siri, and then Google Voice as Google Assistant as well as Alexa. So all these things which works in the basis of natural language processing only. Whatever the commands we are passing, that commands, the voice command that will be interpreted, right? That will be converted into the text format, and that based on the text information, based on the information which we are passing, right? Background, there are a lot of process which will goes in the background, and that information automatically converted into other type of maybe based on the queries which we are passing. So that will suppose if I'm asking what is the time now, right, that question will be interpreted and based on the connector resources, right? Suppose any web server or any web pages, right, and that will get the data from that sources, and that results will be given to us, right? So very similar to that, I was explaining about that Ask Ava. So that was the one of the application which was used in the banking sectors, again especially in the HDFC Bank. They were introduced this Ask Ava, so that when we compared with the normal customer handling, right, the normal customer processing or handles the queries in the customer call service, right? So this Ask Ava, so which responded faster than how we human being responded to the customer queries, right? So it solved more than a million or billions of queries, right? Again, the average time which takes to responses to the query, it is near about not even seconds. It's almost a 0.4 seconds not to provide a responses to the customer's query, right? Also, we discussed about the Turing testing, right? When we talk about what is meant by the Turing test, that means that suppose no, I explained with the diagram that if there is a human question error as well as, right, are they, I mean there will be a human question error, and so there will be the responder, whether it's a computer responder, the other side there will be the human responder, right? The questioner should not realize that whether he is getting the answer from the human responder or the computer responder. If I'm continuously asking the question to the responder, right, I should not differentiate that whether I receive the questions or the right answers from the human responder or the computer responder. At the latest stage, right, the answer will be checked whether the computer responder has given the correct answer or the human responder has given the correct answers. Based on the accuracy, how fast they give the results, right, and the machine will be identified that whether it is an intelligent machine or not. So this is based on the Turing test process, right? Also, we discussed about the some of the ongoing projects which is currently developing by the industries. Like I discussed about the IBM Watson, which is especially used in the medical industry, where doctors really they can with the help of that the deep learning IBM Watson methods, right? Immediately within 2-3 minutes, they will try to find out that what type of disease which the person has, and then solution to those diseases will be immediately recommended to the doctor. Based on that, thousands of images will be got from the human or the patient, and that will be fed into the IBM Watson, where it consists of high power processing units. It will take within a 10 minutes or 5 minutes time. The complete analysis will be done based on the images which is given by the doctor. Immediate decision will be suggested, or the solution will be suggested by the IBM Watson. Also, we discussed about the Facebook Detectron Pro, which really used for identifying the exact object size, shape, and the distance between the two objects. When you talk about the object detection, which is used in the Detectron. So suppose if I'm giving the image or real-time image, video or image, whatever it may be, right? It will try to identify the exact size and then shape of the object. So that will really helps to identify the distance and the element which are related to the object recognition technologies, right? So this is again one of the ongoing technology which is currently developing by the Facebook research team, I could say that, right? And then we discussed about the deep mimic as well as the image enlarging method, right, which are now developed by the Google, as well as we discussed about the OpenCog. Again, OpenCog is the technology in West, right? And we are trying to the scientists, they are trying to make Andro humanoid. Again, example for that OpenCog technology is that our Sophia robot, right? I think already we talked much about the Sophia robot, right? So these are the few things, few example applications, right, existing as well as developing application we discussed under the topics of the applications of AI. Then we started discussing about what else we discussed. Then we discussed about intelligent agents. When you talk about intelligent agent, right, any model, right, and it has to follow the specific values in order to find out a solution to the specific problem, right? So for example, if I wanted to develop a self-driving car, before developing it, I need to make sure that there are four parameters which have to be considered. When you talk about the four parameters, PEAS, when you talk about this piece, performance, environment, and then actuators, and then sensor. All these the four parameters which has to be considered, right? Based on that, I'll develop a model so that will fulfills all these the four categories, all these four parameters, right? Again, we discussed about when we talk about the performance something that what type of output which I am expecting from the model which I am developing. When you talk about the self-driving car, again, I expect that accuracy, there should not be no damage, and that model which has to follow all the traffic rules, as well as I expect my comfort journey. There is no hard braking, no jerking, right? And I expect the comfort journey from the self-driving car as well as, and I need to reach the destination on time, or I could say that as quick as possible. So these are the few parameters I could consider in the case of the performance. Again, when you talk about the environment is something that where are the model, the artificial model, which is going to interact, where it is going to play a role, where it is going to work. Again, when you talk about self-driving car, the environment could be the road and the traffic signals, right? Again, whatever the object is, no, it faces in the road or street, right? All these things, right? The traffic signal or the signboards, right? All these environment, all these objects, which will be calling as the environment. But when the vehicle is moving on the road, and so there should be the communication, there should be some message that should get from the environment, right? Suppose if the vehicle is driving, I mean, which is running on the road, suppose if the vehicle is standing before the signal, is waiting for the signal, right? Again, the vehicle will have a camera. The camera will keep on sensing the signal as well as the other information. Based on the signal, whether it is green, automatically the signal should be sensed based on whether it could be based on the camera, or whether in case with the help of the sensor, or the radars might be with the help of other communicating devices, right? Might be the PR sensor, might be the other navigation parts, right? All this information, all these components, which are going to interact together, that is going to get the information from the environment, and that information, we could say that, so this information can be collected through sensors. I could say that that information will be passed to the machine learning model. So that model will take a decision. Suppose if after receiving the green signal, from the vision processing, and immediately it's supposed to start riding. That means that it has to apply, or it is supposed to press the accelerator. So that pressing the accelerator with the help of the actuators. When you talk about the actuators, which are actual components, which are present in the model. I could say that for the self-driving car, again, the accelerator, brake, and then wheel, and then steering, right? All these things might be the engine ignition. All these things, which are comes under the part of the actuators, right? When we are finding a solution or building a mathematical model, and we need to consider all these factors: performance, environment, actuators, and then sensor. Also, we discussed about the different case studies or example through which we find out the different PEAs for medical analysis. I mean, the medical analysis system or healthcare system, I could say that. We discussed on the online tutor, right? By the way, so we have identified the multiple problems. Also, we discussed about more on that performance, environment, and then actuators, and then sensors, right? Then we started discussing about different types of agents. We discussed about the autonomous agents. When you talk about the autonomous agents, right, the agent will take the decision by its own based on its previous knowledge as well as experience, right? Again, when you talk about the rational agent, again, very similar to the rational, we discussed about think rational as well as think and then act rational. The rational agent is the agent which is going to implement only the right actions or the optimal solution based on the problem, or based on the available solution. It is going to implement only the optimal solution, right? Whenever it solve a real-time problems. Also, we discussed about different types of agents. We discussed about simple reflex agents. Again, in that, what we discussed. Can anyone quickly tell me what we discussed in the simple reflex agents? So that agent, it does not refer any previous history or previous knowledges, right? It is a simple if else based condition. Suppose if I'm developing a model or developing any something, right, like a program, if my room temperature is it needs to check my room temperature, right? I'm writing something that I'm developing one object that for the purpose of my weather monitoring. So I set a program that if my room temperature exceeds 35, automatically my AC should be turned on, right? In that cases, this model does not follow any previous history or any other knowledge base or any other action which taken in the previous. It does not follow any previous record or track, nothing. Whenever it meets this condition, if my it will keep on sensing my room temperature. If my room temperature is exceeds more than 35 degree, automatically my AC should be turned on. That is a simple reflexive agent, I could say that, right? Again, when it what is the problem with this? Gokul Nair, mute yourself. Okay, sorry. And so I was talking about simple reflexive agents. When you talk about simple reflexive agent, it is going to follow only the if-else condition. Other than that, so it is going to check only the temperature based on the temperature sensor, whatever which is I have added in the module, right? And if my temperature is more than 35, it will just simply turn on the AC. And it does not sense about any other information or any other process or any other objects. It does not sense about whether the person is present in the room or not, right? Whether it's a night time, whether it is daytime, it does not consider about any other factors. To avoid that, we are going for the model-based agents, right? In that cases where the multiple conditions will be followed. Based on that, it will keep on checking all these conditions based on the conditions, whatever the thing which mentioned, and it will take a decision. As that, I could say that if any person in the room, right, then that time it will start sensing the temperature. First condition. If there are some person in the room, and then if the temperature is more than 35, that cases it will turn on the AC. Again, very similar to that, if there is no person in the room, automatically that should turn off the AC. So these are the some of the things which we discussed under the model based agent. right? Model driven agents. Then we discussed about the goal based agents. When you talk about the goal based agents, right, all these the steps which are going to taken by the agent, right, that always which focuses on that the optimized route or optimized solution to reach the goal state, right? All the operation which will be considered only based on the goal. Again, I could say that the example of the sales traveling problem from reaching one place to our source to the destination, right? Automatically, in case if the person traveling in the middle, in case if the person got any traffic or any delay due to some unexpected situation, right? Automatically, that will try to find out the alternate path through which, right, the person can reach the destination easily or quickly. So again, so this is again one of the example of the goal based, right? Again, very similar to that we discussed about utility based, right? And then that it will keep on sensing whether the customer is happy. Based on the customer history or customer happy, and then it will try to find out or it will try to update the solution automatically, right? So these are the concepts, right, which we discussed or we covered so far in the unit 1. If you have any doubts in the unit 1, whatever the recap which I given, and quickly you can write it. Thank you for your responses, Bharat. I did not notice your responses. Other than that, is there any other queries which strikes in your mind so that I can clarify now? Then we'll move to the unit number 2 or chapter 2. Is there any doubt which comes to your mind based on the topic which I covered? Okay, I'm getting quite responses. No. Okay, I hope it's whatever the things which I have recapped, I think it's clear for all of you. So this gives me confidence to move to the chapter number 2. Don't hesitate to ask the doubt, suppose if you have, right? Or otherwise also you could personally can approach me and you can ask your doubts, no issues. Next, I will start with the unit number 2. Inside, under this unit number 2 or chapter 2, we'll be majorly discussing about a different problem solving method, problem solving techniques, right? So this especially focuses on what are the different strategies or different methods through which we'll find out a solution, how a real-time problem can be solved, and we will discuss about the multiple problems, real-time scenarios, and how we'll find out a solution. A solution means again how to find out an optimal solution for the real-time problem which we are taking into the consideration. So these are the things which are going to cover. Before that, so these are the objectives of the chapter 2, right? At the end of the chapter 2, as a student, right, you all will be familiar with the different algorithm which I'm going to explain about. The first thing is that you will be familiar with that the breadth first search, right? Again, so I think the fundamental concept which you already learned from the data structure, I hope you might be knowing about the basic concepts which are like graphs, trees, and then what is breadth first search and then depth first search, right? So this later part will have the complete discussion about what is this, right? And so this is the second of the second unit. And before that, we'll have some other information or some other topic which is to be covered. And the second thing you will be learning about depth first search, and then you'll be learning about a uniform cost search, and then IDW deepening search, bi-directional search, and then A star, and then AO search, right? And so these are the few algorithms. So these are all comes under the second part of the chapter 2. Then other than that, what other objectives you will be learning? So for a given problem description, so I think we in the second experiment, right, practical, we identified a problem statement. Based on the problem statement, we identified a solution also very similar to that. For the given problem description, you all will be able to formulate in terms of state space search problem. When we talk about a state space search, again, search is something that a state space search is something that, so if there is a initial state and there is a goal state, so say for example source to destination problem, and what are all the different routes through which are different stages you are crossing, so that will be calling as an intermediate states, through which you will reach the goal station. All these things, which will come under the state space search, that we will discuss, right, when we covering this specific topic, right? and then you will be learning about and you will be able to understand how the state space can be used during your search process, as well as how these states can be represented by the features with the help of the different algorithm as well as the different notations, right? And how we'll find out the optimal solutions, right? All these things we are going to cover. Next, these are the contents of this today's presentation. First, I'll be talking about the introduction to the problem solving, and then I'll be covering about the problem solving agent. So this is very similar to the intelligent agents, but these are all some of really focused on problem as well as solution. And then we'll have the discussion on formulating problem. Later part, we'll have multiple examples through which we will try to find out the solutions. In case if the session ends, join the session after 10 minutes. Whatever the recording which I'm making, that has to be saved. It requires sometimes. Then later we'll try to find out the searching for the solution, and then after finding the solution, right, we will be measuring whether the identified solution is the optimal solution or not. And then later part we'll discuss about this searches, breadth first, depth first, and then as I mentioned, right? Again, so there are different categories: uninformed search as well as informed search. So this we will discuss in the later part also, right? As of now, I'll start with the problem solving introduction, right? When we talk about the problem solving introduction, problem solving, right? I was talking about an agent. When we talk about an agent, agent is something that which I could say that intelligent agents. When we talk about any intelligent agents or a problem solving agent, right, which has the ability, whenever if I'm giving any problem, right, based on the problem which I'm going to give, it has to analyze the process and it has to find what are the possible solutions, and then it need to take the correct solution or correct steps or correct sequence of steps. I could say that it has to take a correct sequence of steps to reach the destination or in order to complete the task which I assigned to the model, right? So when we talk about an agent, agent can find a sequence of actions that achieve its goal when no single action will do. So there should be many number of actions, right, which is accumulated actions that will reach to the goal session, right? But by following all these intermediate states, so we will end with the goal state. So this is what actually the problem solving agent is trying to do, right? So when we talk about the method of solving the problem through AI, which in which we are trying to find out this search space, right? The process of defining the search space and then deciding the start and then goal state, right? I'll explain this complete scenario with the Google navigation applications, right? In that you will be selecting, you will be turning on your Google map application, Google Map, and then if you wanted to move from one place to other place where you are really not uh, know the exact path through which you can reach the destination. Say, for example, for easy understanding, I'm taking an example. I wanted to reach from Rizvi College of Engineering to the Bandra station, right? In that cases, what is my first step is that I need to identify my initial state. Currently, I'm in Rizvi College of Engineering, but I wanted to reach a Bandra station, right? In that cases, the initial state which has to be identified, that is the starting position, deciding the start as well as goal state. Here the goal state is that end state or where I wanted to reach finally, right? According to my example, I could consider my initial state will be a Rizvi College of Engineering, but my final goal state is that Bandra session, right? Through different routes or different paths or different roads or lanes or crossways, right? I need to reach the destination, right? So this will try to finding the path from start state to the goal state through the search space. When you talk about the search state space, which are the intermediate phase through which I can reach the destination. For that, I could say that suppose if I'm no if I'm inside the campus, right? Suppose if I'm in the first floor, first thing is that I need to get down from the steps and then I need to come out from the campus. I need to exit from the college and then I may take left turn or right turn, right? And then I may reach to the Carter Road. Once if I reach the Carter Road, from that I can take left and then I can reach to the Pericross Road, and then I'll through that I'll cross Turner Road, and then I'll reach Bandra Talao, that big signal what is there, right? And I don't know exactly what is the name of the street which is there. Vivekananda Marg, what is that? So I need to cross that street, and then through the big lake, right? And then finally I reach the destination. So this is what all the path which I am explaining. So whenever you are turning on your mobile, and you will be continuously, you will be getting a message, right? Take a left after 20 meters, take right and after 20 meters or 100 meters, right? You need to take left, or you need to take U-turn and follow the surface. All this information you'll be getting your Google Map application whenever you are selecting a driving mode, right? If you are using the source destination with the help of the Google Map. So all these information are all these intermediate steps which helps to reach the destination, that is called a space search. Is it clear for all of you? What are the thing which I was explaining? Is it clear for all of you? What is this search space? Quickly can write it in the chat box. And I inform all of you to quickly write the attendance in the chat box in case if you have missed. Does A star search also fit into the search? Basically, the search is going to be the common process, but how it does the search, and after that how it is selecting how and based on which node it meets, that completely varies. Searching is common, but how there are different methods when we talk about the search engine, when depth for search as well as breadth for search, right? The visiting which is going to be common, but in which order which is going to visit the node, it is going to reach the intermediate elements or other vertices, that is going to be different. But fundamentally the search process which is going to be common in all type of searching process. Is it clear for is it clear, Bharat? Okay. Right? I hope it's clear for all of you, right? I'll read the definition also, right? When you talk about the space search, is the process used in the field of computer science, including artificial intelligence, what we are discussing, as well as machine learning, which is a successive configuration or the states of instances are considered with the goal of finding a goal state with the desired property. So here I'm going to consider here the desired property might be based on the different parameters which I was explaining with related to the self-driving car, whether it is a comfortable or whether it is a shortest path, right? Whether it is some other aspects, right? Whether I need to reach quickly, right? By the way, so based on the inputs which you are feeding, right? No, suppose if I wanted to reach, quickly to the Bandra station. Instead of going to the Carter Road, right, I will take a hill road. So I feel that will be the shortest path. Very similar to that, based on the different criteria which we are feeding to the intelligent agents, that will try to take a decision, right? So this, the intermediate spaces or sequence of intermediate spaces or searches which happens, that is called a space search. Is it clear for all of you? So I'll move to the next one. So again, in this, uh, where finally whatever the agent which we are going to use, that is a goal based agent, also we discussed in the goal based agent again, so that could be called as a problem solving agents, right? Whatever the thing which are going to use, right, all these things which commonly called as the goal based agent as well as the problem solving agents, because at the end all our steps or all our solution which are going to find a solution or which is going to lead to the reaching the goal state, right? Again, when you talk about the problem solving agents, right, use atomic representations, and the states of the world are considered as a whole with no internal structure visible to the problem solving algorithm, because sometimes it may look like a blockboxing algorithm, right? But there are multiple instances or multiple steps which has to be continuously adapted out of the possible way. Suppose if I am reaching the Carter Road, again I will find a multiple options. Out of the multiple option, now again in that situation also my algorithm is supposed to take the right decision, whether I need to take left or I need to take right. Again, if I am taking right, again after reaching certain place, again so there could be the multiple possibilities, whether I may take a left turn or right turn. So based on that information, periodically it has to take a right decision that should be intimated to the users. So again, so this is one of the important property of problem solving agent. Now, When you talk about the other elements, right, which are related to the problem solving agents, right, the first thing is that the goal based agents that uses more advanced factored or structured representation are usually called a planning agent. So here when you talk about a planning agents, right, where the planning agent which uses own intelligence based on its previous history. So for example, I could say that suppose if I already used one route for with the help of the Google map, when I select the same source and the destination, right, and the Google map will automatically suggest the path which I've already used. Out of if it found out that it is a shortest path, right? So that route will be automatically suggested by the Google, right? Again, in that cases, the agents which are more intelligent, which are more advanced, based on that the decision can be